So today in 9.4, instead of graphing parabolas in standard form, we're going to graph them in vertex form. Basically what this means is I can present an equation to you in multiple formats, and you need to be able to graph it no matter what format I give it to you in. So in 9.2, we did standard form, so that was y equals, standard form was y equals ax squared plus bx plus c. And so that was what we did last time, where we did the AOS. And remember, we used A, B, and C. We did the AOS, we did the vertex, we did the y-intercept. Okay, so that was standard form. Today we're going to talk about vertex form. On your Unit 9 test, you will get questions in standard form and questions in vertex form. So you need to be able to know how to work with both of them, okay? So to start, what we're going to do is we are going to graph a parabola using a table of points. So rather than using the AOS and the vertex and the y-intercept, we're just going to plug values in to get values out to make points. So we have a table here that has x and y, so we're going to take that x value, plug it in to our equation, which is y equals x squared, to get a y value that gives us a point. So if I plug -3 into x squared, that's going to be -3 squared, which is what?
Positive 9.
Positive 9, good. What about if I do -2 squared?
4.
Positive 4. -1 squared? 1. What about 0 squared?
0.
Good. 1 squared?
1.
2 squared?
4.
And 3 squared.
9.
So what did you notice about the y values? Were any of the y values negative?
No.
No? So does that mean, am I going to have anything down here?
No.
No, I'm not going to have anything below my x-axis. I'm not going to have any negative y values. So I want us to take a minute, and we're going to graph all of these points, connect them to draw a parabola. Ready, set, go. So we have all of our points. Now the basic shape of the parabola is something that we learned last time. Remember, it curves kind of like a U. So we're going to connect our dots using that shape. Okay? Yep. And so something that's important to remember about parabolas is, and about quadratic equations. So a quadratic equation is anything with an x squared. Yes, ma'am.
Oh, are you going to count me off if I did straight lines with a ruler on
No.
Straight lines.
But do curves. Yes.
Can we talk about that?
Straight lines.
No, curves. Yeah, so we want a curve like this, but no, I will not, as long as your points are in the right spot. Okay, but something we need to note is that every quadratic formula or quadratic equation, every quadratic equation has this basic shape. A quadratic equation is anything with an x squared. Anything with an x squared has this basic shape. So it does have a curve. It's not straight like the absolute value one that we did. Okay? It will curve, making a U shape. So what we need to talk about now is the location that the graph can go. So this basic parabola that we just drew can be shifted all around the coordinate plane. When I talk about shifting, that really means transformations. It can transform.
So if it was just like +1, it would just, all the points would move.
Yep. So if I have a +1 behind the x squared, okay, the location is important here. If I have a +1 behind the x squared, that means I'm going to go up 1. And really that means my vertex, well, actually, no, I lied. That means all of our points will go up 1, okay? So all of those points that we just created would just go up 1. If I have a -1 behind the x squared, then all of my points will go down 1.
Wait, this is like transformation.
Yep.
I
Yep. So what we're going to do in this next graph is we're going to graph the original parent function, which is the one we just did above. So we're going to graph that verbatim, just copy paste. Okay, then we're going to shift everything up 2 and then down 2. I'm going to do each one in its own color if you would like to also do that. So here is the original one that we just graphed. Okay, now we didn't have room for 3, 9, but that's okay. We had room for 1, 1, and 2, 4. Now, excuse me, the second equation has a plus 2 behind the x squared. So what that means, that took me really off guard, but I'm okay with it. What that means is I'm going to go up 2 for all of my points.
Oh, so you don't add 2?
No, we go up 2. So I take this first one on the left, and I'm going to go up 2. Here's my new point. Then I'm going to do this one, up 2. Here's my new point. From 0, 0, up 2, new point. Up 2, and up 2. So now I've got this parabola.
Oh, and now we have another one which goes down.
Good. So then the last one has a minus 2 behind the x squared. So that means we go down 2. Now we go down 2 from the original.
So the thing that's on 0.
Yeah.
Will it always start on 0?
Yes.
Wait.
From original. Did I spell original right?
ORIGINAL.
Okay. So from the blue one that I did, I'm going to go down 2, down 2, down 2.
Where did you get the original? Just from
I regraphed it from the top, that first one that we did. Ta-da! So we have our original in blue. We shifted up 2 for orange. We shifted down 2 for pink. All right, so on the next page, we are now going to talk about horizontal shifts. These are also transformations. Now, the location of the transformation for horizontal is different. So if you notice in number 1, it says, what's the basic shape of a parabola for y equals x plus 1 squared? The plus 1 is inside the parentheses, yes, versus up and down was after the square. This one is before the square, okay? Now with these, they are opposite of what we would normally think. So since it's plus 2, we're actually going to go this is plus 1, we're going to go left 1. Okay, it's opposite of what you would normally think. So positive is left, negative is right. So for number 2, we have an x minus 1 before the x squared. So that means we're going to go right 1. Okay? So for this example, once again, we're going to do the exact same thing. We're going to graph the original, the one from the very beginning of the notes. Then we're going to graph the next 2 in 2 different colors. Now, this second one, they shouldn't be the same sign. So let's make this second one x minus 2 squared. Sorry, the third one. So you should have y equals x squared, y equals x plus 2 squared, and y equals x minus 2 squared. Okay? Okay, so here is my parent function, my original function. In the second equation, it's a plus 2, so that means I'm going left 2. So all of my points are going left 1, 2, left 1, 2, left 2, left 2, left 2.
But if it's outside of parentheses,
It's up or down. If it's inside, left or right. Yep. So then this last one is x minus 2. So we're going to go right 2. From the original. Right 2. Right 2. Right 2. Right 2. Right 2.
Pause. Does that mean we have 2 lessons?
No. So then, here is, okay, so this part is what it's going to look like for you guys on your homework. It's combining them together into one, okay? So if we look at letter A, I have x plus 2. So plus 2 is in the parentheses before the square. So is that plus 2 telling me to go right, left, or up, down?
Up, down. Left, right.
Left, right, because it's in the parentheses. It's plus, so it's going left. So we're going to go left 2. And then what is this minus 1 telling me to do?
Down 1.
Down 1. So you've got a couple different options here, okay? Option 1 is you can always graph the parent function and then shift all those points from there.
So this one there will only be 2.
Option 2 is to go ahead and take your vertex. So your vertex is that bottom point, right? That's normally at 0, 0. So you can take that vertex and shift it and then go from there. That's what I'm going to show you. So my vertex is normally at 0, 0, but I'm going to go left 2, down 1. So left 2, down 1. So here is my new vertex.
Wait, do we have to memorize what a
Parabola looks like? Yes. You need to just know that it's a U.
Oh, so is it always going to be that original?
Okay, so I shifted my vertex. Listen. I shifted my vertex. I shifted my vertex. Now the points are going to stay the same, okay? So the points from 0, 0 were up 1 over 1. And then from that point, it went up 3 over 1. Okay, so if you look up here, from 0, 0, it went up 1 over 1 and then up 3 over 1. Yes? Okay, so I'm going to do those same points here from my new vertex. Up 1 over 1, up 3 over 1. That is the point for a parabola. Now, once you get into Algebra 2, we will do more advanced things with our parabola, but for now, we just need to know that we go up 1 over 1, up 3 over 1. Okay? Now, what is required of you is just these 3 bottom points. You will see that on your on the notes key and probably on the practice key. It's just those bottom 3 points, but you're welcome to add the up 3 over 1 points as well. But if you just want to do the vertex and then go up 1 over 1 and then draw your parabola from there, you can. So for number 2, or letter B, I guess, what is this minus 1 telling me?
It goes
Right 1. And what does the plus 1 tell me?
up 1.
Up 1. So from 0, 0, I go right 1, up 1. Here's my new vertex. Good. Then from my new vertex, I go up 1, right and left 1. And then from each of those points, I go up 3, but I kind of run out of space, so we can just do these 3.
So if you ever run out of space, just...
All that's required of you is these 3 points. Okay, you do not have to do the up 3 over 1 if you don't want to. I think it makes your graph look more complete, but just those 3 points. No.
Oh, can I keep doing that?
Yes, I like to, if I have room for it. Letter C is exactly like letter A, so we will just go ahead and go to the next piece. Okay? So the next piece, which is our last part that we're going to talk about, is reflections.
Oh, that's upside down.
Yep, so that means we would be opening upside down rather than right side up, okay? So remember how we talked about when A was positive, it opened up. When A was negative, it opened down in 9.2? Same thing here. When there's a negative in front of the x squared, then it opens down. So what that looks like on my graph is instead of it opening up, it opens down. We use the same points, we just go down with them. So we start at 0, 0, and then instead of going up and over, we're gonna go down and over 1, and down 3 over 1. Like this. It is Tuesday. Okay, so putting all of this together, we're going to talk about something called vertex form. So that's what we've been working in. Vertex form is this equation here. So it puts the right, left, and the up, down together, and then also the opens up or opens down, okay? So we have this list of things that will help us decipher what's going on in vertex form. If A is positive, then the graph opens up.
Up.
Yep. If A is negative,
Down.
then the graph opens down. Good. If H is positive, so notice where H is. It's inside the parentheses. H, it's just representing that number, okay? If H is positive, that means I'm going left. It's opposite of what you would normally think. If H is negative,
Right.
good. It's going right.
Wait, if some notes doesn't on yours, like it skips over it. Like the find the verb.
Okay, if K is positive,
It's going up.
good. Notice where K is. K is outside, or is after the net.
Wait.
K is after the square, so it's going up. And if K is negative,
Wait. So
it's going down.
A is what's A?
Yeah, my notes PDF is old. So yours says find the vertex without graphing the following. So letter A is y equals x plus 4 squared minus 7. So my vertex comes from the shifting right, left to the shifting up, down. Okay? So
Right, left.
am I going right or left?
Papa.
Left.
I'm going left. How many? 4. Now, if I'm going left and it's a coordinate point, would that be a positive or a negative coordinate point?
Negative.
A negative coordinate point. So negative 4 is my x value. And then am I going up or down?
Down.
Down how many? 7. So I'm going negative 7. Okay, so AKA, when the left or right value leaves the equation, it changes its sign.
Also known as.
Also, no, I don't know, AKA.
Why haven't I also known as? AKA. You're like my best friend, AKA Jerry.
Yeah, my best friend, AKA Jerry.
Jerry, I've never heard that.
Okay, so
You would
we
know.
pull it from, so that's why this is called vertex form, is because we can literally figure out where the vertex is from the equation. So letter B says y equals negative x plus 3 squared. So for my vertex, now my vertex has nothing to do with this guy. That guy's just telling me whether I'm opening up or down. So does this one open up or down?
Down.
It opens down. Now my vertex comes from the number. So if I have a plus 3, am I going right or left? Left. So what will my vertex number be? Negative 3. Now if there's nothing back here, what does that mean?
Zero.
Good. It means plus 0. So 0.
So plus dollar.
What that means is that we're not going up or down. We're staying at the same spot. Okay, and then the last one is letter C, which is y equals x squared minus 2. So is this one opening up or down? Are we focused? Up, because it's positive. Now, am I shifting right or left at all? No, because there's nothing in parentheses. There's nothing between the x and the squared. Okay? But then there's this minus 2 behind the x squared. So what does that tell me?
You're going
Down 2. So for my vertex, I'm not shifting right or left at all. So that's going to be 0, comma. And then I'm shifting down 2. So does that sign change? No, it stays the same. So negative 2. Okay?
Just keeping you on your toes. Is that a negative on ours?
positive. There we go. Yeah, I have my notes here now, so we're good. We're good. We're good. We're good. Okay, so letter A on the last section says to put it all together. Friends, let's focus for like 5 more minutes, okay? So we've got x plus 2. So what does that tell me?
It's going up. No, left 2.
Left 2. And then squared minus 1 tells me
Down 1.
down 1. So I'm going to go left 2, down 1. Is this one opening up or opening down?
Down. Oh, shoot. No, it's opening up.
Opening up. This is positive. Okay, good. So from my new vertex, I go up 1, right and left 1. Those are the only 3 points you're required to do, okay? So from there, you can boop, 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 sketch.
If we do, like, it's just like small.
I don't know. Okay, letter B, what does this minus tell me? What does this negative tell me?
It's going to flip down. It's
Good.
going down.
Opens down. So it reflects. And then what does this minus 1 tell me?
Right 1.
Right 1. Now, do we go up or down at all? No, this is a plus 0, so we're not going up or down. So we're going right 1, and then we're opening down. So instead of going up 1 over 1, we're going to go down 1 over 1. Okay, last one, letter C. What does this negative tell me?
I don't even know.
Good, opens down.
Does that apply even if there's no parentheses?
Yep. And then since there's no parentheses, am I going right or left at all?
No.
No, but what does the plus 3 tell me?
Up 3.
Up 3. So from 0, 0, I go up 1, 2, 3. And then I'm opening down, so am I going to go up 1 over 1 or down 1 over 1? Good, down 1 over 1. Okay, so this is vertex form. Vertex form is a lot easier to graph, takes less work to graph than standard form. Standard form, we have to go and find the axis of symmetry, the vertex, the y-intercept, reflect over the axis of symmetry, all that stuff. With vertex form, it gives you a lot more information that you can actually work with. So it's actually a lot easier to graph in this form. But you have to know how to do both, okay?